3 Ukrainian cruise missiles crossed into Russian airspace above the Black Sea. They were racing toward a gas terminal located off the Krasnodar coast. An S-400 battery near Anapa, Russia's most advanced air defense system, stood in their way. For the Russian operators watching their screens, it appeared to be another quiet morning, but they had not yet seen what was hidden behind the Flamingos. It was a strike package designed to overwhelm, confuse, and punch through every layer of defense. The Ukrainian FP-5 Flamingos flew in a loose formation, only 200 feet above the waves. Their composite fuselages cut through the salt air at 540 miles per hour. Each missile weighed 13,000 pounds. Yet on radar, their signature registered as something closer to a pelican. 40 kilometers inland from the coast, the Russian 91 N6E Big Bird radar swept the southern horizon. The operators watched returns that simply did not make sense. The phased array antenna could track 300 targets simultaneously under ideal conditions. But these targets were not cooperating with standard detection logic. The operator saw ghosts on the display.
As the data points merge,
intermittent contacts flickered through wave clutter, appearing for 2 sweeps and vanishing for 3. Something was out there, and the velocity data proved it. However, the system could not decide exactly what it was. The detection problem was not the radar itself, but basic physics. At 200 feet above the water, the Earth's curvature creates a shadow that ground-based radar cannot see through. The 91 N6E sits on a truck chassis about 26 feet tall. Geometry limits its line-of-sight detection against sea-skimming targets to roughly 22 miles. The S-400's legendary 250-mile range assumes high-altitude targets, not missiles hugging the wave tops. The Flamingo's designers understood this geometry and built a weapon to exploit it. The airframe is built from E-glass fiberglass composite. Woven glass fibers are embedded in epoxy resin over a honeycomb core. This structure provides high structural integrity without adding significant weight. More importantly, it helps the missile defeat incoming radar beams. At 7:03 hours, the Flamingos crossed the 22-mile detection threshold. The Russian 91 N6E finally achieved a stable classification on the lead contact. Velocity was 541 miles per hour at an altitude of 190 feet. The heading was 047 degrees magnetic, straight toward the gas terminal. The profile matched a cruise missile, and the S-300 battery confirmed this 8 seconds later. This redundant information arrived too late to change the tactical situation. The battery commander had perhaps 50 seconds before the engagement window collapsed. The 92 N6E Gravestone fire control radar slewed toward the contacts to build a precision track. Behind the first Flamingo, 2 more contacts resolved into hostile tracks. Behind those was something slower and much more numerous. The commander ordered the engagement without waiting for S-300 coordination. The launch sequence took 4 seconds from the command to ignition. The 92 N6E transmitted trajectory data to the missile's onboard computer. The gas generator pressurized the ejection system, kicking the 48 N6DM clear of the tube. The interceptor cleared the vehicle at 100 feet per second before the solid fuel booster ignited. The 48 N6DM is a 2-stage interceptor nearly 23 feet long. The sustainer motor ignited, and the missile began receiving mid-course guidance updates. In the terminal phase, the onboard semi-active seeker took control. The lead interceptor's proximity fuse triggered 40 feet from the Flamingo. Tungsten fragments shredded the missile's tail section and severed its hydraulic lines. The first Flamingo tumbled into the Black Sea in pieces. However, the second interceptor lost its lock at the worst possible moment and self-destructed. 1 Flamingo was down, but 2 were still inbound. Their fiberglass skin continued to soak up radar energy like a sponge. The gas terminal was now only 14 miles away, representing less than 90 seconds of flight. The S-300 requested a handoff, but the process burned seconds that no one had to spare. The data link was still negotiating when the second Flamingo crossed the 20-mile threshold. 4 more missiles were launched in rapid succession from both batteries. For 6 seconds, both systems engaged the same target. The S-400 interceptors arrived first, scoring 1 proximity hit and 1 clean miss. The S-300 missiles found only a debris field where the cruise missile used to be. 2 Flamingos were down, but $8.4 million in interceptors had been expended. Both batteries were calling for reload vehicles that were still 4 minutes away. Meanwhile, the 3rd Flamingo was already past the engagement zone with its warhead intact. Behind it, the track count on every Russian scope in the sector continued to climb. The display transformed into total chaos in just 90 seconds. Some contacts were fast and faint like the Flamingos. Others crawled across the scope at 120 miles per hour, appearing as propeller-driven drones. Others matched nothing in the threat library. Too fast for drones, but too slow for cruise missiles. The opening salvo had been the Flamingos, but the main strike was something else entirely. The contacts that mattered most were designated Hostile 07 and Hostile 08. These were signatures the operators had been trained to recognize since the sinking of the Moskva. These are the long Neptune missiles. They were created when Ukrainian engineers asked, what happens if we make it bigger? The extra space is almost entirely dedicated to fuel, not a larger warhead. The MS-400 engine now has enough propellant to push the missile 620 miles. The warhead did grow to 570 pounds, simply because the larger airframe could carry the weight. The long Neptune also deleted the original radar seeker entirely. In its place is a guidance computer running 3 navigation modes simultaneously. Primary mode is GPS, receiving updates from satellites every second. Secondary mode is inertial navigation, using ring laser gyroscopes to track position without external input. The S-300 commander recognized the Neptune signature and pushed the classification up the chain. But the command post was still struggling to reconcile data between batteries. The Neptunes crossed the coast near Vasilovka, 40 miles southwest of the terminal. 2 Neptunes were inbound at 560 miles per hour, followed by 14 drone contacts. The Russian defenses had only 14 interceptors left, against 16 confirmed threats. The battery commanders prioritized the cruise missiles. Hostile 07 took 3 hits and disintegrated over the coastline. Hostile 08 was luckier. It jinked hard as the interceptors closed, dropping behind a low ridge at the exact wrong moment. The interceptor lost its lock, detonating 50 feet away and peppering the Neptune with fragments. However, Hostile 08 emerged from behind the ridge with its control surfaces still functional. The guidance computer noted the damage and recalculated the flight parameters. The speed dropped to 490 miles per hour, but the 570-pound warhead remained dangerous. A Book M3 battery 15 miles east of the terminal had been watching the chaos. The cruise missiles had already passed through its zone. Now, the drones were his problem. His 9S-36 radar painted the lead contacts. This system is optimized for tracking targets in the medium altitude band. The classification came back as one-way attack drones. The hard part was deciding how to engage 14 of them with limited missiles. The Ludi's drones are propeller-driven and roughly 12 feet long. They carry 75 pounds of explosives in the nose and use a cheap, efficient airframe. However, the guidance system is highly advanced. The Skynode flight computer uses a downward-facing camera to capture frames of the terrain. It runs a visual algorithm to estimate movement against a stored reference map. This allows for a position fix accurate to within 15 feet without needing GPS. When the Russian Pol-21 jammer began denying GPS signals, the drones did not panic. The Skynode processor noticed the GPS degradation and shifted trust to the visual system. The drones kept flying straight toward the gas terminal storage tanks. The surviving Flamingo, however, was still the highest value target on the scope. The Buk commander decided to engage the cruise missile and ignore the drones for a moment. 2 9M317M interceptors roared off the rails, accelerating past Mach 4.5. The first missile arrived from behind, triggering its proximity fuse at 30 feet. Tungsten fragments shredded the Flamingo, and it hit the water 400 yards short of the beach. The gas terminal survived that specific threat, but the drones flew on. A wounded Neptune was also still inbound, having been ignored for the last 4 minutes. The Buk's proximity fuse struggled against the composite skin of the Ludi's drones. The radar returns were barely stronger than those of a large bird. 12 missiles were fired, resulting in 7 hits and 5 misses. The battery had expended $13 million to to destroy $200,000 worth of hardware. Meanwhile, Hostile 08, the wounded Neptune, was using a Kalman filter to stay on course. This algorithm compares GPS and inertial data to filter out jamming errors. By the time the missile entered the jammer's radius, it had switched almost entirely to inertial guidance. The probability of impact against the 45-acre tank farm remains near 100%. The Neptune crossed the coast at 300 feet. The Buk radar finally painted it, but the engagement window had already collapsed. Hostile 08 cleared the last ridgeline at 07:11 hours. The guidance computer initiated the final dive toward the terminal coordinates. The Neptune hit Tank 7 center mass. The warhead punched through the steel shell and detonated inside the liquefied petroleum gas. Superheated gas expanded instantly, rupturing neighboring tanks and spraying flaming fuel. Tank 9 exploded 4 seconds later due to a failure in its pressure relief valve. This created a BLEVE, a boiling liquid expanding vapor explosion. The resulting fireball rose 200 feet into the air. The remaining 8 Ludus drones crossed into terminal range a minute later. Pantsir batteries engaged them, but 4 drones managed to get through. They struck the pump house and the transfer manifolds, starting uncontrollable fires. Tank 15 went through a BLEVE at 7:15, followed by several others. 3 pressure vessels ruptured within 15 seconds of each other. Satellite imagery later measured the combined fireball at 600 feet across. By 7:20 hours, 22 of the 30 storage tanks were destroyed or burned. The loading rack and the rail yard were completely gone. The fire burned for 3 days. Bye for now.